Or if you get a time, please check from the, any resources, how to sync or synchronization windows. I plan I can show you the video here. Means you want to sync the time. You want the time to happen at the same time. That's called the synchronization. They're going to happen at the same time. So we look, this concept of deadlock, it's also a part of synchronization. They happen at the same time. Now we look at the background here of what we see here. We may not see all of this, but what we see, we look these important points, such as critical section, Mutex Lock, Semaphore, and yeah, I think this Semaphore, I think I will stop from here. Whenever I read Semaphore, I remember the sophomore. I don't know why. Maybe because of 4 is there. Semaphore and the sophomore. All right, so we understand this concept. Very, very, very important, right? So let's look here. Why do we need this synchronization? Okay, we need to look the concept of process synchronization, and we understand the critical section and whose solution can be used to ensure consistency of shared data. We understand what does it mean, critical section problem, and what solution can we give. I repeat once again, you will need these in your exam. So please spend enough time reading them, understand the concept. To present both software and hardware solution for critical section, and also to examine several classic process synchronization problem, and also be able to explore several tools that are used to solve process synchronization problem. Now, when we say the synchronization, this is what we mean. This is the definition of synchronization. In operating system, processes can execute concurrently. That is synchronization, right? But when they are executing, they may be disturbed at any time, all right? Or they can have partial completion. When we say to be interrupted, what do we mean here? In process scheduling, interruption is also same as to say preemption. You can interrupt it. Don't interrupt me, don't disturb me. It can be disturbed, right? So preempted means it's going to be disturbed, to be other one process came, another one is coming, the higher priority is going to be given. So it can be interrupted at any time, right? And then another one. When they are happening at the same time, they are accessing the same data, so which may result in data inconsistency because both of them, they are sharing, they want to share the same data, so it can result in this data inconsistency. Okay, now what will we do to this one? Now this is the solution. When you have inconsistency because of the resource which is shared, then you need to define the sequence. Who is going to take a turn, or you are going to set the order, what to be done, so that you can be able to avoid the data inconsistency as well, right? So now you come to, you understand the background of this one, of synchronization. You understand? Process are happening at the same time, right? So when it happens at the same time, they're going to be data inconsistency. Now we need to do what? To solve this problem by defining the sequences or the order of the process to access what? The resources. Remember, they are sharing resources. Okay, so now This is another important point to understand. What does it mean, rest condition? Okay, what does it mean, rest condition, right? So in rest condition, I'm going to display here, and you try to differentiate from the deadlock. Okay, I'm going to display the definition of it. You read it, understand, digest it, and try to differentiate from the deadlock. There we go. Take a few seconds. You understand? I did it purposely so that you can understand, you can read it and understand it. Okay? What is rest condition? You can put in one line. What is the rest condition?
Sometimes when the program is running well, and then instead of running only one, it's running more than one.
Okay.
When process have like say whatever time and say first time maybe something like that. So the system, the operating system cannot decide that which one will occupy the working state, something like that. Because it's same whatever time and say first time.
Okay. Yes, Chris.
So basically, it's like a process is trying to do multiple things at the same time. But the nature, like the process has like the process that you're trying to run. Like for example, if it's running 3 processes at one time, but the system favors like one process rather than other, but it's easy to handle and move fast. So it gives the preference to the first one rather than the that goes on so far. Basically, it depends on the specs of the system, not depends on the arrival time of the first time. Basically, what the system thinks will make it quick to end so that you can run the other process after that.
Take an example. Can I sing and teach at the same time? But I can do both, right? I can sing. I can even teach. Can it come? Can it come at the same time?
But basically, it's up to you which one.
Which one you're going to do first, right? Yes. So I may take an example. You, the nature of you is just only accept one. Just teach, don't sing. But for me, I feel, oh, if I sing for you, you'll feel so happy, so good. And then when you feel so happy, so good, I can teach you and understand very well. You understand? I want to do both at the same time. But because of the nature, we only want study, period. I can't do both. So the same case as you both of you explained, process is multitask. But the nature of the device only accepts favor one operation at a time. Don't bring 2, only 1. So this is what you call rest condition. Okay, the rest condition. Now look here now. Rest condition occur when 2 process or thread attempt to access the same resources at the same time and cause problem in the system. Now, how do we differentiate rest condition and deadlock? Here, 2 thread or 2 processes, they want to access, the same resources at the same time. That's a rest problem, right? So how do we differentiate them? The difference between this, maybe as you think this as well, there is no dependency, right? I don't depend on what you have. We all depend on what we need. In a deadlock, you have a pan, I have an oil. Give me, I give you. You can't go. But here, what do we have here? Here we have two of them, they have opportunity, but they don't know who's going to take the turn first. So that's called the rest case. I'll give you a simple example. I want to do this. Now, okay, I think this is the what happened? Do you notice what happened? What happened? What happened? This is what happened. One switch, it can off and on all the lights. These lights. Now, what if I want to off this? What will happen? Is it possible? I need to shut all of this. That's a rest condition. Right? Let's say I want to off this light because I'm wasting this electricity. It can't because they're all connected to one switch. Same case, the AC centralized AC which we have here. If you on down there, means all the rooms here, they're what? They're supplied, but you need to on it. If you on there, it will be okay. But the best example to give you here is what? This light which we have here. One switch connects to many lights. Okay? So you can't be able to provide this. So this is an example of what? Of rest condition. Right? The rest condition. Now we have types of rest condition. Okay, the types of rest condition. First type, critical section. Second, read, modify, write. And third condition, no critical section. Okay, no critical section. So for the critical section, it says that the segment of code where processes access shared resources such as common variables, perform write operation on them. So both here in the critical section, we have multiple processes and they share the same resource, take the same light which we have here. And we have, multiple lights, they all share the switch, right? And they all need to perform certain action on it. For example, I want to off it. I can't off it. If I off, I off yours. If I on yours. The same, that's called critical section. And read modify. When two processes read a value in a program and write back to a new value, it's often called a software bug. So it's going to write on one, and then it's going to create or to have a new value on it. So that's going to cause a changes. So this is the types of rest condition. This is critical section problem. We have the processes, set of processes, P0, P1, Pn, and then each process has a critical section segment of code. So you can read what happened. Process may be changing common variables, or it may update a table or write a file. When one process is in a critical section, no other may be in a critical section. Means you have ability to write, others cannot be there. Otherwise, it's going to cause or to be changed. Okay. So critical section problem is to design a protocol to solve this. So I want to show you the important point here. This you can read them. This is a solution which is given. I just want to come to the important point here. There's something which you have seen, right? So there's a person called Peterson. He gave an algorithm to solve this critical section, right? He proposed what you can do by mentioning two operations, so two process solution, load and store. So that's what he mentioned here. I just want to go fast to the important point here. No, this one. Yeah, I think this. Okay, I just want to come to the important point. All these are very important, but I want to come to the best one. Yeah, I want to come to the Mutex Lock. Critical section or critical section is a case when we are having the rest condition, right? So now, what does it mean, a Mutex Lock? Please note down this definition. Mutex Lock, rest condition and a critical section problem, they are all connected. These points we read you today, semaphores. So, Mutex Lock. So a locking mechanism is used to synchronize access to a resource. So what does it mean? Here we have a synchronize. Means, what does it mean, synchronization in OS? What does it mean? What does it mean, synchronization? We start from the synchronization, right? Means what? Two or more processes occur concurrently at the same time, right? So now we need to decide in rest condition which one to take the part. So to do that, we need to apply different techniques. One of them is the Mutex Lock. So Mutex Lock, we want to implement to help the process access the resources, okay, by using this Mutex Lock, right? This mechanism used to synchronize access to the resources. You share resources, so we need to have Mutex Lock to help each resources, to share. I mean, each process to share the resources. So that's a definition that you need to understand. So why that one was designed? Just to solve the critical section. Okay, that's why a Mutex Lock was introduced. All right. So these are the way Mutex Lock has come into picture. So it has these two sections to protect. First, acquire a rock, means you have to request a rock. Second, you need to release the rock. Ask the lock, I want to rock because I'm accessing the resource. Once you receive the lock, then you release if your time is over. So that's the concept of Mutex Lock. Remember, if you understand synchronization, critical section, and the Mutex will be very easy for you to understand. Okay, so the next part here, the cost to acquire, release must be atomic, must be small, or it must take less time. So these are the important points. I'm just highlighting the best point which you need to understand, right? This one. And Mutex Lock here, what does it mean? All right. And this. I told you we don't have enough time so that we can execute this in a language, in a C language or in other language. We can create them, right? So it will be easy for you to understand. The last phase, which is known as a semaphore. All right. What does it mean, semaphore? This is the meaning. Semaphore is the next level of helping the process to achieve synchronization without any problem. They're happening at the same time, they share resources, and then we need Mutex Lock. You understand Mutex Lock? Acquire, release. Right? Now, Semaphore came as an extra way or update of helping or achieving the synchronization to happen in harmony. I forgot to mention, when we say synchronization, sync means harmony or in peace. Okay, so semaphore, wherever you will see semaphore, it will refer as an integer variable. Okay, so why do we need it? To solve the critical section problem. Okay, so how the semaphore is going to solve this one? It does two things. Number one, wait. Number two, signal. You wait and then you signal. In Mutex, what method do we use? Mutex, what method do we use? Acquire, release. But here in the semaphore, what do you do? Wait and signal. I'm waiting, I can signal you. I need it. I need it. So this is the way semaphore is used. So it's very beautiful. When you get time, you can read it. So this is what I mentioned here, just to conclude it. Semaphore are better than Mutex for process to synchronize the activities. Underline this word. You understand? Synchronize. You understand what Mutex is. You understand what semaphore does. In fact, these are the functions which you build. In Unix, in the C language, you call wait and signal in a semaphore, right? And in the Mutex, we call them release and acquire, okay? So look, this is semaphore is an integer as is, okay? Just these are the bonus point which you can, the bonus notes which you can go on and read. This is the way it is written. Wait and the signal. So wait you call P and signal you call V, function V. So definition of the wait operation, wait, S is what? What is S?
Signal.
Signal, right? S is a signal. S, so for more, right? Semaphore, not semaphore.
Semaphore, yes.
And is what? Integer. I'll repeat once again here. Is an integer which we pass in the function. Okay? The parameters for those who are doing database design. All right. So again, here it is here. What is S?
Y
Integer, right? Why? This integer is greater or equal to 0. You are what? Busy. Right? Busy wait, right? And if you decrement, then you have to decrement, right? Now, definition of signal operation. Now, what is this? What is S?
Semaphore.
Semaphore integer, right? Now you have to add the time or to keep increase. So this is the operation. You understand the function here, and you do this. It's very simple if you understand the concept. You can create any program if you understand this. All right? So this is the simple way to understand the semaphores and the previous one, Mutex. I mentioned once again, I'll ask you this. Okay, please be prepared. Right? All right. So any question, any doubt? All right. So if there's no question or doubt, then we will meet in the next class.
Thank you, sir.
Thank you too. Yeah.